A very warm welcome to all of you. I'm Prasadini Vikramsinghe, an engineer and the coordinator for the Green Tech Center of Excellence for Hydrogen in Sri Lanka. Let me start by introducing the Center of Excellence for Hydrogen. Our mission is to empower industry professionals and speed up the development of a thriving green hydrogen economy. We do this through cutting edge education, training, and knowledge sharing initiatives. Our programs span the entire hydrogen value chain, from safety, production, and storage, transportation, and utilization. We offer a range of comprehensive training programs, workshops, and webinars. Additionally, we work to foster collaboration between academic institutions, research bodies, and industry leaders to create a robust and sustainable green hydrogen agenda. Before we dive into the webinar, I want to express our heartfelt gratitude to USAID SARAP for their invaluable support of our program in Sri Lanka and to the government of Sri Lanka for their ongoing support of GreenStat. Today, we are delighted to have Draeger as our esteemed partner for this event. Draeger is a global leader in medical and safety technology, known for their innovation and excellence. We are privileged to have Hirendra Chatterjee with us, the head of business development at Draeger Safety India Private Limited. Hirendra is an expert in industrial safety solutions and OSHA certified qualified safety sales professional from the USA with a background in chemical engineering and a postgraduate degree in marketing. He has been a key figure in the Indian safety industry for over 25 years. He also serves as a member of Bureau of Indian Standard Chemical Committee for Standardization, bringing a wealth of knowledge and experience to our discussion today. Additionally, Draeger has kindly provided a free digital white paper on hydrogen safety for all participants of today's webinar. So stick till the end. Without further ado, I'll hand it over to Hirendra. The stage is yours.
Thank you very much, Prasadini. And it's a pleasure for Draeger to be able to be associated and support the Center of Excellence, specifically from Sri Lanka. But we see that there is a huge amount of positive response that we have been getting from this part of the world, wherein we see people from the neighboring countries, mainly from India and other areas, joining in this series of knowledge sharing sessions. So I'm very happy and really privileged to be able to share some valuable information for the participants who are joining today, and people who are not able to join, we still will reach out to them through the electronic media. So before I start, a little about the background and the knowledge that is coming to you from this knowledge source. Draeger has always been an innovator and been there for more than 135 years, developing and creating technology for life. So the first valve was actually produced way back in 1889. We have been inventing things in the anesthesia section where our medical division plays important role, but have been providing solutions for very, very critical life-saving applications in different parts of the human exposure and corporate objectives. Even in this part of the world, when Tenzing Norway and Edmund Hillary conquered Mount Everest, which we all know is the privileged part here, they actually were protected using Draeger breathing apparatus. And that's what is the history with which we bring to you the Draeger's present sources, which are spread in more than 50 countries, including Sri Lanka, India, Nepal, Bhutan, and other areas, with spread out production and manufacturing sites. Obviously, we bring in a lot of new products as we develop, very importantly, keeping these patents as a very high level, but do spend a lot of money on research and development on our new fields, wherein a substantial amount of our market revenue goes in there, and with a lot of direct sales and service employees spread across the world, with our headquarters still based out of Germany, but the production and sales and service sites, as you would see, has spread across the globe. So it's a very, very quick manner for us to be really able to support and make Vision Zero a reality. This particular knowledge session, we do not want to really make it boring. So you guys have an opportunity to really interact with us, although we are not able to give you an audio and visual connection. But please feel free to type in on the chat messages, and our colleagues and panel of experts are also on this call from Greenstat and from Draeger side, who would take us jointly and make this knowledgeable session more effective. So with this little introduction, I once again thank everyone, especially all those who have joined on this working day morning to spend their time to understand little on the hydrogen safety part of it. And I'm really thankful that I'm able to present to you a part of what Draeger really does in this domain and how we are developing the whole hydrogen economy. Thank you very much. So if you see the way the hydrogen economy is really developing, it is developing really in bounds and leaps with different sections. So right from the green energy evolution, which is happening around in the world, this energy is coming into the production side of it. And then there are already existing user industries which are somehow had been using hydrogen in the past with the conventional or the orthodox matter of wetting it. But now is the time when they're looking for more on the green hydrogen side of it. Add to that is the mobility sector and the rest of the sector, which is really improving on utilization of hydrogen in their day-to-day work. And it is that particular sector which really is growing much, much faster on the whole economic front. And that's the reason why hydrogen in its production, storage, or utilization becomes very important for all of our day-to-day work or related industries, which are really investing and trying to make this global uh, contribution, I would say, towards the environment. And that's the reason I would really emphasize that it is the responsibility of each one of us to really, whichever part of this whole hydrogen economy that we are connected it. And I can see in the webinars, we normally get people from different, so there are people from the institutions, people from the government agencies, regulatory affairs, or even in different parts of the hydrogen economy cycle. Some could be involved in production part of it, some maybe on the storage or transportation side of it, but each one of us are really connected with this hydrogen, and that too on a greener side. So basically the whole solution and the concern that happens is that the production as is still being done on hydrogen on a more fossil fuel based basis, so which is still happening, and that's the way it is developing. But then there is investments which is happening to get the energy mainly on a greener side. On the storage side, there are different ways in which people are storing hydrogen today and transporting it in different parts of the world. There are projects which people are working on R&D sites where it will not be limited to within a country or a region, but people are investing and R&D is being done on cross trans country, transcontinent, into way this hydrogen could be transported in a safe and secured manner. So coming back on the whole of this economical side and the safety part of it is that obviously hydrogen is extremely flammable and explosive. We've had our earlier webinars, and those are available on the Greenstat websites or on LinkedIn sites, where you can actually go back and look into what hydrogen has on hazard side. But let's move further, because we are right now developing these knowledge sessions where we are going in a step-by-step manner to enhance the knowledge of the industry, to empower them to take some informed decision for the hydrogen safety part of it. So one thing which is really, really very, very, I would say, is a myth in the industry, where people think that hydrogen is lighter than air, And that's the reason why it will dilute or disappear fast in case it is kept in an open atmosphere. Yes, you are right from a physical property point of view, but it is also very important that this hydrogen, in case in a leak situation, is detected. And the reason why it can be done and the way it is actually done is that it can actually be detected either in a gaseous condition where it is in a gas form or even on a flammable condition. So these are the two ways and stages in which hydrogen leakage or hydrogen safety concerns could normally be detected, and these conditions, before it really becomes a hazard or it becomes a serious concern for the plant and people around it, it is important to detect this hydrogen to ensure the safety part at your respective plant locations. This could any be in a refueling side, it could be the electrolyzer side, it could also be in your normal storage or on transportation part of it. So let's understand what really drives or detection technology for detection of hydrogen in these different two state form, the physical form of it. Also very critical is the speed with which this detection can be achieved. One is good to know, over after a period of time, but by the time in case there is a delay in able to detect this hydrogen leak, it could then pose a much higher risk for plant and people around it. So the speed of detection is also very, very important when we talk about the detection matrix, which is the topic for today, or we talk about the technology with which hydrogen detection could be done at any of the hydrogen economy life cycle part of it. And this can only be achieved, and that's where Draeger has really worked for last many, many years, because hydrogen is not new to the industry. However, the green hydrogen and the hydrogen economical development which is happening is due to the industry. And that's the reason why we see a lot of new people from the technical side, from the educational institution side, from the R&D sides, or even the industrial people who are investing new into this business, has to really understand that the speed of detection can be achieved by using a matrix of detection which is fast and safe. So not only do we really want to just do it faster, but we also want to make sure that it is safe enough for ensuring the safety that is required. Now, many of you may be already familiar with point type of gas detection. Now, this is a type of detection which is actually achieved by a technology wherein you have a sensor and then you have a transmitter behind that sensor to be able to detect the leak. And this is typically done in a hydrogen case by measuring the lower exposure limit, which we call it as LEL. And this LEL detection can be achieved using a simple point gas detection technology. But the challenge with the detection technology in point guard is that the gas has to travel to the point guard. And that's the reason why a newer technology has been introduced. And this is really catching up on the hydrogen detection side of it, where it is using the technology of ultrasonic gas detection using the acoustics or the sound that really a gas leak will produce around the places where it has there. And that's the reason why even if a conventional gas detector is not able to pick up the gas leak, the ultrasonic gas detection is able to do that because it is based on a different technology of identifying the sound, the ultrasonic sound that a gas leak would produce in an eventual case of doing that. So mixing not only these two technology, but also trying to then figure out that in case the hydrogen then goes in a flame condition. So from a gaseous state, if it has moved into a flammable state, we should be able to detect the flame of hydrogen in a different manner than what normally happens with another flames. And I'll talk about it in a few slides later, where you will understand that why hydrogen flame detection is a different ball game altogether when it comes to technology behind detecting this using a flame detection, which can be researched and developed using this technology for adding a second layer of protection in the detection matrix that we are talking about. So the using the three detection technology, it is very important, and one should not really neglect or do just with one. So if you see, if you have a series of battery, you actually put in point type of detectors, then you place few of flame detectors on a line basis, and also add it up with ultrasonic gas detectors. Now, the reason why we really need to do this and use a detection matrix, because if you just have a point detector, and this is very important for all of us in the technical domain to understand that a point detector, by the virtue of it, is only a detector which measures the concentration either in LEL or in ppm, and the gas is measured at a point. What it really means is that the hydrogen gas has to travel to the gas sensor or to the transmitter nearby to be able to be measured. And this is a little limitation of the technology, because this uses basically a catalytic EX sensor technology where the gas has to travel to the sensor to be able to be really detected. And this is where you normally see hydrogen detection in LEL is done using a catalytic EX bit sensor. So what it really does, and it's important for us to understand the technology which is being used in different gas detections. And so the hydrogen detection normally in most of the cases where it is explosive limit detection is done using catalytic EX sensor technology, where the oxidation of the combustible gas really changes the resistance of the Winston bridge, which is then is picked up by the transmitter. So the change in current that happens in place of placement of or the identification of hydrogen gas then increases or disturbs the Winston bridge, which gives a signal, and that signal is picked up by the transmitter to give you a detection thing. At some places, you can also do hydrogen detection using electrochemical technology, but this is on a parts per million basis, and this is more prevalent. The electrochemical sensors are used conventionally in gas detection for measuring toxic gases or oxygen. So these are not really specific to hydrogen, but yes, some of the electrochemical sensors can have measurement of hydrogen in ppm, but electrochemical sensors normally has an electrolyte which is filled inside a very, very small cell, and the flow or the presence of a gas, in that case could be a toxic gas or oxygen or even hydrogen, will create a current between the measuring electrodes or the reference electrodes, and that's how the concentration of the gas is measured using the detection technology, which is then a part of the complete gas detector. Now, these are the two detection technology which has been prevalent for a long time. And the third technology of gas detection, which is prevalent in the industry, is using an infrared sensor. Now, in an infrared sensor, the measurement happens because of absorption of infrared by the presence of the gas in the infrared sensor. Now, this technology is not suitable for hydrogen. So please note it down very, very clearly, and do not make a wrong decision of installing an infrared LEL or an explosive gas detector for detecting hydrogen. Hydrogen, by virtue of its physical property, will not absorb infrared lights. And that's the reason why it will not detect using the infrared sensors in its technological limitation for infrared as a technology. So we have to come back on to different two technologies. From a sensor point of view, it can either be detected using an catalytic bit sensor, which is normally called a cat ex sensor. Some of the people in the industry call it can also call it LEL detector or a detector with Pellister detector. So these are the different terminology which the industry uses, and some limited cases when you want to really detect the hydrogen leak in very, very fine parts is also can be done using an electrochemical sensor. Now, these sensors could either be installed on a portable device or on a fixed device, as the case may be. But when it comes back to our area of work, mainly in the plant side, most of this is achieved by installing it on fixed gas detection system. And that is the reason why we need to then add this technology with a third matrix of ultrasonic gas detector, which actually covers a larger area around it. And what does it really do is that it picks up the gas, even if the gas is not coming up towards the sensor. So it picks up the sound wave. Now, please understand this in a manner where you would see that let's understand that this is a potential part of leak on a flange, on a hydrogen compressed line. Let's assume that there is a gas leak. Now, even if your conventional point guard gas detector is placed very, very close proximity to this, and if there is a wind direction which is taking the hydrogen leak away from the detector, then the point type of gas detector will never detect any gas leak. Unlike our ultrasonic gas detector, which actually will pick up the sound frequency of the ultrasonic sound that this leak is creating in that environment. So even if the gas, due to the wind direction or because of any reason, is not reaching to a ultrasonic gas detector, it still picks up a leak which is happening beyond it. Also, even the leak, after the leak, the dilution of the gas really happens, because we all know the property of hydrogen. It has a tendency to go up and disperse, but the sound that it creates at the leakage point is well picked up by the ultrasonic gas detector. And that's the reason why, as the scientists have really done that, and the industrialists have always been very successful in ensuring plant safety by implementing a matrix of gas detection technology at their plant sites so that they are all safe and secure. So let's understand the phenomena behind this whole detection technology. So when you have a gas leak, so we will go from left to right. When you have a gas leak, the ultrasonic leak detectors are the first one to pick it up. Now, this gas could either be explosive gas or not an explosive gas, could be anything else. Now, if it is an explosive gas, then if it gets ignited, immediately a jet fire is created, and this fire can then be detected using a flame detector, as we have already discussed. I will talk about flame detection a little more in future slides. But if the gas immediately gets ignited after the release, then a flame detector will be able to pick it up at an early stage. Suppose it does not do that. Okay, there could be a situation where they do not find an ignition source, and the gas that has been released does not find ignition. Then it comes into a vapor or a cloud form, and this one will then, in a cloud manner, if it ignites, then you create a vapor explosion or a flash fire. And this is again where the flash fire happens. And if it does not, then it moves into a liquid release or an ignition, where you then get a pool of fire, or you have created a situation where you're able to again use flame detection. But this is the area where most of the conventional point type gas detector is helpful or is able to protect the gas leak on the system. So either we actually catch it right at the starting using ultrasonic gas detection, club it up with conventional point guard detectors, and at all these points where it actually catches flame, we also keep a detection matrix of flame detection. And with this event tree, we are actually able to ensure that irrespective of the situation that could be in any of these plant location, we will ensure that before this really gets into a major explosion or hazard, we are able to detect and alarm and take preventive actions for the detection and safety that can be a threat due to hydrogen scenario. So using the ultrasonic gas detectors and flame detectors, as we spoke about, the flame detection specifically for hydrogen is very, very typical because the property of hydrogen as a fire is very different because the flame that it creates cannot be seen with naked eye. Unlike your methane based or an organic compound based flame, which really can be seen using naked eye or using basic background information. When it comes to hydrogen fire, it poses really a bigger risk because it is not visible in daylight. Also, it radiates a very little heat, and this is odorless. Obviously, the hydrogen fire is absolutely odorless, so you will not even know it by way of people moving around in that area. And in addition, ultraviolet light or the infrared radiations that are emitted in hydrogen flame is very different than what it really does in a hydrocarbon scenario. So when you have a hydrocarbon flame, it can be picked up very easily, whereas for hydrogen, you need a different technology to be able to detect that flame, and that is what is actually achieved using flame detection, which is specific for hydrogen detection. So in an typical plant scenario, you have to create these matrix, whether it is in a compression facility, whether it is in storage areas, or even in the production area of electrolyzers or other technology of biogas conversions and others that is being right now being the practice for most of our areas of work that is happening. So moving forward, it's very important that we actually understand the plant which is being right now under the responsibility of various people. So if you are working in any of these research projects, if you are from an educational institutions trying to consult on the safety side of hydrogen in any ongoing projects, it is important to understand what type of detection matrix can we implement for a foolproof system. It is not about just one detector. I mean, I keep hearing and discussing with people, or even they are setting up a refueling station, and they say, "Oh, with the OEM, we have got one gas detector which has come, and that is good enough for me because anyhow, my hydrogen will disperse or it will become not really a concern even if it leaks." But that is not the case. There are serious incidences which has been recorded around the world, and as people are getting newer facilities developed or maintained or set up, the detection of hydrogen from a safety point of view is becoming more and more critical. And that's the reason why matrix of detection technology is found to be the most safe and secure way of carrying out this. Now, you can always do that. So that's all about background work of it. I don't know. I think I'm keeping good on the time. So we'll use around 30-35 minutes to look into that. And then if you have more questions, we can actually discuss that more with our technical experts also present on this webinar. And we would like to hear from you people about your concerns and about the situation or your case studies that you are right now into it. So I would encourage you to please, based on what we have discussed till now, if you can put in some text about your area of application, then I think it will be more useful for the rest of the people in the webinar to also learn from your experiences. Because I do not want to really make these series just one-sided. So we do a lot of interactive work after each webinar, wherein people have been very, very open to write about the applications or the scene or a scenario under which they are working in hydrogen economy or in any of the spheres of their responsibilities, and how can they make that workplace more safe and secure. So this is a typical way of doing things, that you just follow the regulations. So there could be, and this is where the hydrogen regulations right now are quite weak. I would say they are under development in different countries. As you heard, Prashadini, that Greenstat as a consulting partner is working with the government of Sri Lanka on a very focused way. Similar work is done here in India with a lot of statutory and regulatory bodies really trying to work and understand what best regulations can be built so that that is the minimum mandatory requirement for hydrogen safety in a plant site. But what could be interesting is that if we can make more useful standards and guidelines in code of practices. So learning from the best practices, if you see, if we are able to implement more of the guidelines and best practices, which are much more than the standards and regulations. Regulation is something which you cannot do away with. But with increasing awareness about safety, we move more towards creating these regulations. And I think moving forward in our future webinars, we would bring in more experts who will be only talking about the world standards and regulations which are right now being developed, such as the regulation which is right now being built up, even in our own original country of origin, where Germany has come up now with a series of law where they have writing it, the documentations to create legislations for health safety of people, especially on hydrogen side of it. But more importantly, also there are cases where it going in where if on a hydrogen mobility side, what could be done best in places where a mobility is to be done with refueling of hydrogen, refilling stations, and other part of it where there's a lot of work being written separately in different things. Obviously, there is work going on the standardization sides, and I'm just giving you a glimpse of that. This is not a part of detailed discussion in this webinar, but this is what is going to be coming in future for you, and you will be able to connect with us. And we are helping the industry in taking these actions and taking these initiatives, liaising up, meeting up with regulatory authorities, trying to be in a consultative role, and also making sure that our R&D and other work and the experiences that we are now gaining in different parts of the world. And such is a forum of this Center of Excellence for Hydrogen. I would say Greenstat has done a great job where they're connecting professionals in the same domain industry to be more aware about hydrogen economy and how safely can it be done, whether it comes to the technological side of production, transportation, or storage, but also on operational side. You would see a lot of these work being done together here where we are working it. Also, Draeger is the part of the hydrogen safety community where we bring in information on different areas of activities to bring this up on that. So if you see how we really achieve this at primary level, let's try to detect and prevent leakage by doing this and detecting it early. Very importantly, how can we then also create a secondary source where the ignition is prevented? Now here you use EX certified equipment. You try to create things and infrastructure which is really useful. And if eventually then you anyhow have a pool of fire and how do you use ways to really pick this up? So on a conclusion side, what I can say with my experience of working closely with this industry is that gas detection is actually regarded as a primary explosion protection side of it, wherein you can actually take a lot of help right at the starting of it. And there are a lot of resources which is available with us on our side, and that's the reason I'm leaving this screen for you for some time. You can actually use these barcodes to get into the hydrogen safety part of it. There is microsites which are being developed on Greenstat, LinkedIn. You will find the recording of this webinar, and we can then do many more things to make this workplace safe and secure. I would really like to thank Greenstat for giving us this opportunity to create this knowledge session, or I would say in half an hour, 45 minutes. You cannot really go too much technical out of it. But I hope whatever we could share from a plant safety detection matrix side of it is well received by the participants, and we are now open to take interactive discussions with you for the remaining part of this 5 to 7 minutes that we have on this webinar. So thank you very much, and let's see and I'll request my marketing communication leads to look into any uh, questions or other things if they've had during the session, and we can take them up one by one. Yeah.
Yes, Hirendra, there are a few questions on the chat, if you can have a look.
Okay. If you can just read them out for me.
Sure, I'll do that. So the first question is, explain a bit on exact localization of the leak and leakage for stopping actions recommended when the sensor matrix gives some rough localization of an H2 leak.
Yeah, very good question. So I think it's always very, very critical to understand where do we really place this gas detections and how do we create that matrix. Now, in our typical market scenario, I'm assuming you're talking about hydrogen production side of it. What we really need to do is that you need to really create or do a gas mapping. Now, that is the most scientific way to detect or understand the possible place of leak. And in case that happens, how is the gas dispersion going to affect your plant site based on the location and the schematic that your plants has done that. And I think Dr. Devas Sundaran is asking this. So gas mapping is the best methodology, I think, and there are experts who are doing this gas mapping to identify the location of the gas leak and how it will create a scenario in the case which will happen, and then they will recommend what type of placement of detectors can be done. Now, how do you mix the gas detection technology is also important, because when you're placing your point gas detectors and you're alternatively also trying to do a flame detection or a ultrasonic dyne detections, you then decide the number of gas detectors that is actually to be added in these two detection matrix. And this is achieved by way of understanding and working with the customer on their process plant layout basis, and then followed up with a walkthrough survey wherein an actual study of the location is done, and then we are only doing a recommendation. So Draeger does take up this type of analysis, but there are also help from the gas mapping companies who are expert in doing that. And so we do a double way of identifying the location of the leak and doing that particular study, which is called a site survey or a gas mapping study. I hope that solves this query. And I think this is a very, very common and first query which we normally get the moment people have understood that, okay, yes, I need to implement a gas detection technology, or I need to really be aware to implement that technology. So yes, Dr. Saab, this is available, and this is to be achieved by way of gas mapping and site survey to get that. Yeah, I think Harold, as Mr. Harold Pendelson is on the call and he has raised his hand. So I would really like to take his expert opinion and speak. Yes, sir, please go ahead.
Thank you. Thank you very much. And thank you for a very interesting and good presentation. When it's coming to gas mapping, this is something, as you correctly said, is done when you have set up the design for the plant, and then you will do the simulation. And depending on the meters of pipes and the design setup, you would have also a lot of data, which is correctly based on hydrocarbons, but hydrogen has also been part of the industry for 100 years, even if it's now are changing the usage from feedstock to other applications. However, Gexcon is one of our partners as well, who has for many years developed a methodology for gas mapping and simulations of different scenarios of leakage to build policies and build emergency response plans and so forth for the different plants or for the different applications. So this is actually the quite a bit of experience that can be transferred to the different stakeholders. And also the regulations today, as you mentioned, is based on both descriptive and functional the regulations and policies. The reason for that is that descriptive is what we have in the laws and regulations, but they always lag behind when we have new technology. And the ISO committees and so forth who is working is always 2-3 years behind as well. That's why we have the functional, the descriptive, which really are telling you what you need to do to prove that your design solutions are safe and sound and meeting the intentions of the lawmakers and regulators. So also the Green Stat is actually from the 1st of this next month is setting also up a safety team to support and help clients in this regard with the software that Flex software, the simulations software. And this is also available for all the universities in Sri Lanka. The same in India. We are providing this with the Center of Excellence, and we would have training next month for this software with experts, Gexcon and Greenstat participating in it. So I just wanted to mention that. So thank you again for a very good presentation.
Yeah. I think very, very important feedback, Henderson, that you shared with everyone. So I would recommend to get in touch with Greenstat for any further deep dive. And I also see Vedita De Silva writing on a similar manner. I mean, your question is in line, and I think it's been already answered that yes, most of the gas mapping and modelings were based earlier on hydrocarbons, but specifically on hydrogen. There is very, very important work which is being done with some expert committees and companies, and that is available as a consultative approach. So you can write back to Greenstat and their partners in this, and you will do that. I think we'll continue with few more since we have some time. Maybe Anubhav, can you help us with the next question, or should I just go one by one? So I didn't know which one came first.
On the chat.
Yeah. Maybe let's take a question and answer one first, because that's Q&A. I think that, and then we can go into the chat side.
Sure. So the first.
So which is the next one? And
yeah. So the first question in the Q&A section is that what is the safety response reliability levels of these detectors?
Yeah. So depending on different models, definitely safety integrity levels, SIL 1, SIL 2s are being certified, and it's not only restricted to the detectors, but to the whole detection technology that can be built around the solution that we are offering for a particular place. So I think it's not good for me to just give or comment on the safety integrity level on a generalized basis, because with different detection technology and the different algorithms that we create around detection matrix, the safety integrity can be achieved. And it's also important to know what you really need to make sure that you have extremely integrated system altogether, including your the control systems and the alarm and the annunciations and warning systems all as a whole. So yes, our experts do provide level of different integrities based on the client requirement and the criticality of the operation that is there. So yes, it can be done.
Got it. And there is also a similar question. Consequence assessment models currently available for modeling fires and explosions are mainly based on hydrocarbons. What is the accuracy
so
using these models?
That we just answered by Stubble Harold, and I think more details can be had from Greenstat team. Yeah, so we just answered that. Yeah.
Got it. Going back to the chat section. Yeah.
Yeah, so no, on Q&A, I see a one which says that can you compare a policy regulation of hydrogen, well-established country and the important specifications of our sensors? So yes, this is a quite a deep topic, and most of the regulations are right now being led, I would say, from the European Union, but also some work is being done in our neighboring countries in Korea, Japan, and other parts. In India, I would say in Sri Lanka, I'm not too aware because I'm not really working closely in Sri Lanka, but there are regulations which are quite comparable because hydrogen economy is developing more as a global best practices. And that's the reason why you see that there is a work of global leaders around these different geographical areas. And that's where I would say the regulations which are coming up are quite comparable. There are already existing standards which are being written down. And in agreement with GridStat, we have agreed that very soon, in a month's time or two, we will do a deep dive into the regulations and developing policies on hydrogen detection, because I think now is the right time to implement all that, and we will do a complete session on that. And regarding the specifications of our sensors, what we'll do is we'll take it up offline. We will share with you technical details and specifications. And I think this is a good point that we may probably spend a session in future in next 12 months time where we'll take up on the technology side of it. So I don't want to really push in any particular manufacturer specification, but very important to know what should be the specifications for the right detection of the technology. So that is very important, and we will definitely are taking this as a positive feedback. So Mr. Kumara Jaya Vikrama, thank you very much for that feedback. We will take that with you. Also, there's a question from Dr. S.D. Devarendra. He's asking whether we train in-house person on gas mapping. So if you're asking Draeger, the question is no, we do not do that, because as you heard, there are different experts who are working on gas mapping situations, but we can help you, or GreenStat can help you link to them. So that is how it happens. Also, what you mentioned is the time taken to intervene is also important. Very correct. I fully agree with you, because this is the speed of detection is what we discuss. And that is extremely important. And that's the reason why the response time. So when you look into one very specific specification of the sensor technology, or whenever you select, is the speed of response. So what is this response time to get to T90 or T40 or T60? Now, this is the terminology which the industry speaks about, where 90% of the measured value, what is the time that the sensor technology takes to come to that, is what is detection. And I agree with you. Okay, there's some appreciation about presentations and other things. Thank you very much for that. Also about online condition monitoring scheme proposed for these plants in order to look after detection of plant and equipment. Yes, so definitely the detection technology that we discussed about, the matrix that we discussed today is 100% online and can be a 24/7 system, where it is the whole information system that is built behind it, and the control system can be made available online, and you can have a monitoring which is foolproof, and wherever you are. So I mean, now there are technology which is also bringing it towards smart safety, wherein on your smartphones or on your other connected device, you can have a complete monitoring in of these online conditions. Uh, this detector automatically operates or a manual operation? There's a question from Mr. Prashant. Thank you for asking this. Yes, definitely these detectors are detecting automatically. What it means is that these are online gas detectors, wherein because of different technology that we discuss, when a gas is detected by these detectors, they automatically trigger a response, and that response is captured by the transmitter and the control system. And then you can either build a manual system behind it, or you can have an automated system for action. So suppose you want an alarm to start, or you want a ventilation to start, or you want the power to be cut off. So those are all different decision matrix which can be either automatically or manually operated as an outcome of this device. But to answer your question specifically, these detectors detect automatically, and they are foolproof in their own system. Yeah, again, Dr. SD Hirendra has asked, what help would you provide for incorporating the related standards in the standard enforcement authorities? We can, I mean, actually, we are working very closely with different statutory bodies, different consortiums, different, I would say, consultative agencies and research and scientists, wherein we work with them on the gas detection and safety side of it. And we represent, for example, my own contribution in India is on a Bureau of Indian Standard. We have subcommittees on safety, which we decide and upgrade our standards on that. So there are technical meetings which happen. So Dr. Saab, if you're interested, you can also give your recommendations or your research and your papers to us, and we can link you to these different agencies working elsewhere. A lot of things on Q&A. So I think, I don't know how we're doing on time. I think we have passed the time, but just since we still see a lot of people still on the call and they are interested to hear the question and answers. So I will take a few more question answers. And for the rest of the things, I assure you that if you have put a chat or you have question, we will get back to you with our responses and our feedback on your query. And this is just the starting. As I said, Greenstat and Draeger together under the Center of Excellence for Hydrogen has started these hydrogen safety webinars with a view to initiate and instigate the thought process on safety. So this is only a starting point. This is not the end of the webinar. So we will definitely take each and every question very, very clearly and very seriously. So on a long run, Dr. Saab has written that on a long run, the practice of not providing training of in-house persons could create undesirable long-term dependence. I fully agree with you, sir. Very, very important is to train the people on the site, on the technology of detection which has been installed, on the maintenance and upkeep of these detectors, and on the training of what action do they need to take in case of a detection. So it's easy to detect, but what do I really do if I see that something has gone wrong? And that is where the training and knowledge sharing of these sessions happen. We do carry out a lot of those such sessions and we'll continue to do them. And if time permits, Kumara Jai Vikrama has said, please elaborate on sensor technology related to hydrogen transportation. And did not understand your question completely. If you're talking about how hydrogen is to be transported, then that's a totally different topic. And the sensor that is actually you're talking about here is the detection technology in hydrogen transportation. So that is again is a matrix of technology which is used normally with catalytic EX sensor technology, and it is actually challenging. So the transportation industry, whether it is transported on pipeline, whether it is transported using a cylinder bank or bullets, or it is transported in ships. So there are big hydrogen ships which are right now being built, which is then again having different gas detection systems and technology to be able to solve that. Okay, I think from GE Energy there is some input about some WhatsApp group that they have created. So thank you very much for doing that. No issues. I mean, see, this is a knowledge sharing platform. So we encourage everyone to share more knowledge. We will all learn more than that. So thank you, Narula Jitendra, for sharing that information. I don't know, Anubhav, do we have any others?
So we have Mr. Pedersen to give the final comments. Okay. And what we'll do is we will answer these questions in detail and send it over email to all the attendees.
Absolutely. I would request the chairperson and the CEO of Greenstat, Mr. Sturl Harold Pedersen, to give his closing remark. Before that, I would like to thank you, sir, for this opportunity.
Thank you very much. I just want to give a few comments. First of all, Greenstat has developed a set of policies and regulations for the government, which will go out to the stakeholders in Sri Lanka to get feedback on this regulation. And it is all based on best practices and in all the different areas, in the different industries as well. Transportation, we are just now starting up a large EV and hydrogen project in Sri Lanka for policies and regulations as well. And as everybody knows, at this point, Sri Lanka is in the election modus, and also the responsibility for green hydrogen and its derivatives has been transferred from the PTSL to another ministry, but actually this ministry has not got the mandate. So now there is a vacuum in who is really reviewing and implementing these policies and regulations. So we hope that will soon be cleared, so the new ministry can start working and we can also interact with them. And everybody in this forum who's participating today, if they are interested, please contact us. We are all working together and everybody have valuable input and contribution to it. And then at the last, I would also thank Draeger and our friends Hirendra, who has performed an excellent presentation focusing on a very important area of sensors and sensor methodology and technology, and how important it is to prevent, because the first step in safety is to prevent. It is to create awareness and prevent. And of course, after that, it's a mitigation of how you are reducing the impact of incidents and accidents, so they are not escalating to the larger event as well with a fatal outcome. So this work that we are doing together, and these forums are extremely important to make sure that the transition from fossil fuel to renewable is a safe journey, and people can keep the trust in us as researchers or industry or the government. We need all to work together if we are going to be successful. And this is a contribution which we really appreciate. And I thank you all, and I look forward to the next seminar with Draeger and all our other partners. There is now a lot of new seminars coming up, and also training with some of the important tools that I talked about, which is the computational fluid dynamics software from Gaxcon, but also TNO software for mapping, and other tools as well will be introduced for the academia, which is going to be trained, because one of the important part is that Sri Lanka itself need to take the responsibility. They cannot depend on anybody else. They have to learn it from scratch and have this capability in-house in the country. And I'm sure this will go very, very fast with the collaboration between all the universities, governments, and the industry. So thank you again for the contribution, Hirendra. I really appreciate it, and thanks again, and I wish everybody a really great day. Thank you.
Thank you. Thank you. Have a safe side.